Today we're going to cover lesson 6.5, analyzing graphs. What it's going to do is apply what we've been doing in the functions that we've been created and to draw conclusions based off of the relationships that the variables represent. All right, so our first example here, we have the example of a roller coaster park, amusement park. Think of Six Flags. It's open from May to October each year. The graph shows the number of park visitors over its season. All right, so what we have here, segment 1 shows that attendance during the opening weeks of the park season stays constant. All right, so there's that. And then what's happening in segment 2, it shows what's happening to the line. It's an increase. It goes up. Increase in visitors. Based on the time frame, give a possible explanation for the change in attendance represented by segment 2. So again, this is our time frame here, May to October, so think about it. The first part of our graph is May. And then after a few months, it's going up. What are we thinking about there? All right, so think about our calendar, right? May, June, July. So apply it to yourself, right? What's happening here? There's no more school. So that's one of the reasons why more people are going. What's another reason why? What's happening here? As the months go on, the weather is getting better. So increase in temperature would be both of the reasons why there. And now, which segments of the graph show a decreasing attendance? So take a look at it. Where do we have a decrease? We have segments 4 and 5. And think about why that might be. All right, so think of, again, what happens at the end of summer. It's basically the opposite of what we had up above, right? So school is back in, school starts, and then the weather declines or the temperatures go down. So those are the conclusions they want you to draw from our graph. All right, next example. This is what you will most likely see on standardized tests. They're going to give you examples of functions, and then they're going to give you scenarios, and then they want you to match each with what is true. And so in this case, we have Grace, Jet, and Mike are studying 100 words for spelling bee, and which is which. All right, so let's take a look specifically. Grace starts by learning how to spell many words each day, but then learns fewer and fewer. So there's a graph there that's going to show fewer and fewer words. All right, so where is that going to be represented? That's going to be on the side, right? Jet learned how to spell the same words, same number of words each day. So same number, that's a clue word, right? Something that's constant. And then lastly, Mark started by learning how to spell only a few words, only a few, and then a greater at the end. All right, so GoMath wants you to do it this way, is to start first of all by drawing conclusions this way and then matching, so you can kind of do it whatever way you want. So what do we have here in A? We have that constant rate, right? And hopefully that jumped out at you as you were seeing that scenario, and that would have been here, right? Jet is the same number each and every day, so that's the slope is always the same. So this one is Jet. Describe the progress represented in B. And so take a look here. We have fewer words right away, right? Then all of a sudden it's going to take off. All right, so which one was that? Fewer each day. And then learn to take a great number of words each day. That was Mike. So you could apply those to this idea. And then lastly, let's take a look at C. So the number of words learned right away is very high, and then it levels off. Does that make sense? Grace started by learning how to spell many words each day, but then learned fewer and fewer, and so the rate decreased, and so that would be Grace. And that's how you apply the graphs to the different situations. All right, so here's a good example of another one. Mrs. Sutton provides free math tutoring at her students every day after school. No one comes to tutoring sessions during the first week of school. Over the next 2 weeks, use of the tutoring service gradually increases. All right, so sketch a graph. All right, so no students for the first week, and so a little smaller here, but it would be 0 then, right, to start. It would be on that x-axis. And over the next 2 weeks, it gradually increases. All right, so that would be your graph. It would be then going up. All right, Mrs. Suttons are told that they will have a math test at the end of the 5th week of school. How do you think this will affect the number of students coming to tutoring? All right, so if there's going to be a test, right, what's probably going to happen is it's going to increase even more, so the rate would probably take off at a steeper slope. All right, so steeper slope, higher rate. All right, considering your answers to be, sketch a graph that shows the number of students. All right, so the 6th week, right, was after the uh, tutoring close to the test. So I'm going to retrace that. So the first week of school there was none, and then we're going up, and then once we're getting here, steeper slope. Mr. Sutton offers bonus credit to students who come to tutoring. How might this affect the number of students? All right, so once again, it's going to increase the rate. It's going to make it even steeper. And so whatever point that is that she is doing that, the rate and the slope of your line is going to increase even more. So good practice here, and again, eerily connected to what's going on in our world today with the virus. You'll see bacterial growth, and you'll see this a lot in the news today. They talk of the graph, the curve of the virus, what's happening. So this is what this is basically asking you, what is happening to the population during phase 2. All right, so this is the time, weeks and months going across, the number of microbes, the population of microbes, and you'll see what's happening here is we're increasing in a very high rate, high slope. What is happening to the population during phase 4, and then you'll see finally it is declining, it's decreasing. And to apply, to our world as we're waiting for this now to happen in our nation is the number of cases of people being affected and infected we need them to go down before things can start to open again. All right, so good practice here. What do we have? We have 3 different situations, and this is very practical because there's only going to be 2 of them that are used. So you have to figure out which one is not there and to not be fooled because they're going to try to trick you. So let's take a look at that. Chip begins his ride slowly, but then stops to talk with some friends. After a few minutes, he continues his ride, gradually increasing his speed. In this one, Linda steadily increases her speed throughout most of the ride, then she slows down as she nears some trees. All right, so again, you can do it however way you want. Sometimes it's easier just to get rid of the ones that you know are the easiest ones. We'll match that. So if Linda is increasing steadily, right, so we have 2 examples of that, right? So both of those, or all 3 of them technically could be them, but what happens now? Then she slows down as she nears some trees. So take a look here. Which one shows slows down? This one has slows down but then goes higher again, so that one doesn't make sense. What do we have here? This one is keeping it down, so it's the same, right? And this one is slowing down here. Her speed is going down, so that would be graph 3. All right, so we get rid of that one for Chip. He begins his ride slowly, so we have that on our first 2, then stops to talk with some friends, and then he continues his ride gradually increasing. This one doesn't have an increase anymore, so it would have to be this one. So he's stopping to see his friends. That's not there, but you have to draw the conclusion. If he's stopping, he has to slow his speed down gradually to get there, and then he's going to increase it again. So this is graph 2, so that would be Chip. All right, and then lastly, good practice here of positive and negative numbers. Paulo stood at the top of a diving board. He walked to the edge of the board, then dove forward into the water. He plunged down below the surface, then swam straight forward underwater. Finally, he swam forward and upward to the surface of the water. Draw a graph to represent his elevation. All right, so you got to look at what is being asked here. Here's his elevation, distance above and below. So what is he doing here? Top of the diving board. All right, he's at the edge, and so this is where he has to be. And now he's going to walk to the edge, then dive into the water. So what's going to happen is he is going to go down. All right, he's going to go below the surface of the water, so below. And then he's going to swim forward while underwater. All right, and then he's going to swim forward, then upward, depending on how he does that. And then finally, he is going to be above the surface of the water, depending on how he wants to do that. So again, this is going to determine how far he swam underwater. If he's doing it upward as he's going across, it would look like that in some case. So now you guys are going to practice. You are going to apply the different graphs down below. We have the different situations again, so you can go back to the mini lesson if you want for help. But again, it's pretty straightforward. You have to apply, what do we have, distance from rental site there. And then on this, you're going to practice and apply time and speed to this graph, and then some more science applications there. So any questions, let me know. Otherwise, submit again before 4 p.m. today. Thank you.